Good evening, everyone. Today we will going to see some NCERT Exemplar questions from the chapter Solutions, as you know. So let's start. Disclaimer: the images, text, and other materials used in our presentations are for educational purposes only. We respect the intellectual property rights of original creators and owners. If you are the owner and have any concern or issues, please contact us at sathi@iitk.ac.in and we shall remove the content immediately. Please note that the parts of the content may have been generated using the generative AI, which is experimental. Okay. So let's start with our first question, which is of the NCERT, which is from the NCERT Exemplar number 10. The question says that the unit of ebullioscopic constant is. So you have to tell the uh, unit of ebullioscopic constant. Okay. So this is our first question from the NCERT Exemplar number 10, and the question asks that the unit of ebullioscopic constant is. Okay. So you have to tell the unit of ebullioscopic constant. Now, what is the ebullioscopic constant? It is basically Kb. Okay. K subscript B. Now you have to identify the unit of that constant, and the options given are: first one, Kelvin kilogram mole inverse or Kelvin molality inverse; mole kg Kelvin inverse or Kelvin inverse molality; kg mole inverse Kelvin inverse or Kelvin inverse molality inverse; or Kelvin mole kg inverse or Kelvin molality. Okay, so these are the four options given. So you have to select the one which is the correct unit of this constant which we are asking about. Okay, so you have some time to go through this question, and after that we will continue to the its correct answer. Okay. Okay, now let's move on to its correct answer. So for this given question, the correct answer is the first one, which is Kelvin kg mole inverse or Kelvin molality inverse. If we talk about the solution, the delta TB is equals to kbm. Now, ebullioscopic constant is this kb. That means you have to identify the unit of this constant. Okay, the change in boiling point, or you can say the boiling point elevation, is equals to kb times molality. Okay, m representing the molality. You just have to put the unit of molality here and delta TB, and you can identify and derive that what will be the unit of kb. So from this relation of boiling point elevation, you can rearrange this equation and write it as kb is equals to delta tb by m, right? Now delta tb is nothing but the change in the temperature, right? Change in temperature. Delta is representing the little change in the temperature. Okay, delta is representing the little change and T is representing the temperature. Now, if you are talking about a temperature or a change of temperature, it will always be in some unit which is, of course, of temperature, right? And temperature unit, standard unit used are is Kelvin, right? Not Celsius, but Kelvin. So, the delta T, that is the change in temperature, will be having the Kelvin unit, and molality, you just apply the formula of molality. What will be the formula of molality? That is the number of moles divided by the weight of the solvent in the kg, kilograms, right? You simply just put the formula of the molality here in the denominator, and then according to that, what will be the molality unit, you just put that here, and then you can derive the kb unit. So the unit of kb will be the unit of delta TB divided by the unit of molality. Delta TB unit will be Kelvin and the molality unit will be, let's suppose it is molality, because in the options you can clearly see that the unit is also given in terms of molality. Okay, like simply they write the molality thing. So you can also write the molality. So it will be Kelvin molality inverse, right? Molality will go in the numerator and it will become Kelvin molality whole power minus 1. And you can also write it as Kelvin upon mole per kg, because molality is number of moles of solute divided by the number of weight of solvent in the kilograms. Okay, that weight of solvent in kilogram is in denominator. It will come in the numerator and goes to the power goes to minus 1, and it will come along with the mole, right? So the molality unit will be mole per kg or mole kg inverse, and you can write this unit at this place where the molality is written, and you can write it as like this, and you can also write it like Kelvin mole inverse kg, right? If you take this mole in the numerator, the minus 1 in the power will be there, and the kg minus 1, when it goes in the numerator, it gets removed, and it will become kg. The minus 1 will remove because it is coming in the numerator. So the final unit we are deriving from this relation of boiling point elevation for the Kb is Kelvin mole inverse kg, or you can also say Kelvin molality inverse. Okay, so this is the unit, you can say unit conversion, and we just applied that by using the boiling point elevation relation and find out the unit of ebullioscopic constant, which is Kb. Hence, the correct answer is our first option, which is Kelvin kg mole inverse or Kelvin molality inverse. Okay. Okay, so now let's move on to our next question. Okay, now the next question asked, in comparison to a 0.01 molar solution of glucose, the depression in the freezing point of a 0.01 molar MgCl2 solution is. So, if you compare the 0.01 molar solution of glucose, the depression in the freezing point of 0.01 molar MgCl2 is. Okay, so basically you have to find out the depression in freezing point for a 0.01 molar MgCl2 solution when you compare it with the 0.01 molar solution of glucose. What will be the comparison? How much it will be increased or decreased, that you have to tell. And the options are the same, about twice, about 3 times, or about 6 times. Okay, so we have given 2 different concentration of 2 different solution. You have to compare their depression in the freezing point and then tell the answer. Okay, so you have some time, go through it and try to solve it. After that, we will continue to its correct answer. Okay, let's see. So for this given question, the correct answer is option 3rd, which is about 3 times. Okay, so basically the 2 given solutions, the comparison between their depression and freezing point is basically 3 times. Let's see how. Now, as we know that the depression in the freezing point is directly related to the vent Hoff factor represented by small I. Okay, so according to which the greater the value of I, the greater will be the depression in the freezing point. This is the simple relationship we will use. So the depression in the freezing point in the question asked about the depression in freezing point, and depression in freezing point is directly related to the vent Hoff factor, which is small I. And vent Hoff factor says that if the vent Hoff factor is greater, the depression in the freezing point, the temperature, okay, the temperature which is we are calling as depression in freezing point, that will also be greater. Okay. So the solution is 0.01 molar glucose and the solution 0.01 molar MgCl2. Their respective Ventov factor is given, like 0.01 molar glucose is having I value 1 and the 0.01 molar MgCl2 solution is having I value 3, right? Number of ions you get from the glucose 1, number of ions you get from MgCl2 3. I Ventov factor is 1 and 3 for the respective solutions given in the question. So the depression in the freezing point of 0.01 molar MgCl2 solution is 3 times that of 0.01 molar glucose solution, you can say clearly, right? Because the freezing point, or you can say depression in freezing point, directly related to the I factor, which is Ventov factor, and you can see the I value for the glucose solution is 1 and for the MgCl2 solution is 3, right? So if you compare between these two, the glucose, or you can say the MgCl2 is having 3 times the depression in freezing point from the glucose solution. Okay, so clearly our correct answer is option third, which is about 3 times. Okay, now let's move on to the next one. Okay, so this question asked us that consider the figure given and mark the correct option. We have given this figure where there are two containers which are joining together, okay, at standard pressure, and there are two pistons attached to these two you can say containers. So piston A and piston B. In the first container we have fresh water considered as A, and in the second container we have concentrated sodium chloride solution in the water. That means the solute is NaCl, concentrated NaCl, and the solvent is water in the B container. Okay, the piston A, piston B, fresh water A, and concentrated NaCl in the water as in the B. Okay, now what question asks is that mark the correct option, and the options are given as the first option is water will move from the side A to the side B if a pressure greater than osmotic pressure is applied on piston B. Water will move from side B to side A if a pressure greater than osmotic pressure is applied to piston B. Water will move from side B to the side A if a pressure equal to the osmotic pressure is applied to the piston B, or water will move from side A to side B if the pressure equal to osmotic pressure is applied on the piston A. These are the four options, or you can say statements regarding the given figure. You have to consider these options and then choose the correct answer or correct statement. Okay, we have some time to go through this. After that, we will see the correct answer. Okay, now let's see. So for the given question, the correct answer is option second, which is water will move from the side B to the side A if a pressure greater than the osmotic pressure is applied on the piston B. Okay, now let's see how. So if a pressure which is higher than the osmotic pressure is applied on the solution, what will happen? The solvent will flow from the solution into the pure solvent through the semi-permeable membrane. And this process is called reverse osmosis. Okay, we are talking here in this question about the osmotic pressure. Okay, what is osmotic pressure? So basically, the osmotic pressure you can say is a minimum pressure, minimum amount of pressure you have to apply, or which the solution is needed to be applied on, so that the inward flow of the pure solvent will be prevented across a semi-permeable membrane. Okay, that is the minimum pressure which you need for this process is osmotic pressure, is considered as osmotic pressure. So If the pressure is higher than that pressure, which is osmotic pressure, then what will happen? The solvent will flow from the solution into the pure solvent, okay, through that membrane, semi-permeable membrane, and this is considered as reverse osmosis. Thus, in this case, the water will move from the side B to the side A as per the given diagram if a pressure which is greater than osmotic pressure is applied on the piston B. If you applied here the pressure, outside pressure from on the piston, the water will move from the side B to the side A, okay, as per the osmotic pressure concept. Okay, so that is why we have the correct statement regarding this given figure as option B. Okay, let's move on to the next one. Here, the question asks that 2 beakers of the capacity 500 ml were taken. One of these beakers, labeled as A, was filled with 400 milliliter of water, whereas the beaker labeled B was filled with 400 milliliter of 2 molar solution of sodium chloride. At the same temperature, both the beakers were placed in the closed container of same material and same capacity, as shown in the figure. You can see. So we have two, you can say beakers. The beaker, you are calling the beaker. Beaker is this one, A and B. Okay. This the big one is the container, which is of same material and capacity as of the beaker. One beaker contained the water. Okay, the capacity of the beakers is given as 500 ml. One of the beaker which is labeled as A is having 400 milliliter water in it. And the beaker B is filled with 400 ml of 2 molar concentration of sodium chloride solution. Okay, now at the same temperature conditions, the both are placed in a closed container. So this container is closed from here. Okay, and this is made of same material as the beaker and the same capacity. Now, at a given temperature, which of the following statement is correct about the vapor pressure of pure water and that of sodium chloride solution? Now, this water or pure water and this sodium chloride solution, about this at the given temperature, which statement will be the correct statement as per the given options? So, the options are vapor pressure in the container A is more than that in the container B. Vapor pressure in the container A is less than that in the container B. Vapor pressure is equal in both the containers, or vapor pressure in the container B is twice the vapor pressure in the container A. So you have some time to go through it. After that, we will continue to its correct answer. Okay, let's see. So, for the given question, the correct answer is option first, which is vapor pressure in the container A is more than that in the container B. Let's see. So, when the salt is added to the water to make the solution, the vapor pressure of the solution decreases. This is the property of vapor pressure and the solution which we use here. So, we are talking about vapor pressure. Okay, now what is vapor pressure? The pressure which is exerted by the vapors which is present just above the liquid. Okay, in the you can say in the mathematical term, you can say the vapor pressure of a solution is the product of mole fraction of the solvent and the pure solvent vapor pressure. Okay, so it is saying that when you add the salt, that is NaCl solution, to the water, it will make a solution and the vapor pressure of that solution will get decreases. Why is that so? So this is due to the decrease in the surface which is covered by the solvent molecules, which lead to the decrease in the number of solvent molecules and escaping from the surface which is corresponding to pure solvent. Why this is happening? Because the surface which is covered by the solvent molecules in the solution will decrease, and this will lead to the decrease in the number of solvent molecule which is escaping from the surface. That will create the vapor pressure, okay, which is corresponding to the pure solvent. So the number of solvent molecule decreasing, and that is why the vapor pressure will also get decreased. Okay, when you add the salt in the water, it will decrease the vapor pressure of the solution, and this is the fact that why, because the solvent molecule get decreases on adding the salt to the water solution, and that is why the vapor pressure will also get reduces. Okay, so that is why the NaCl solution will be lesser. The NaCl solution vapor pressure will be lesser than the water vapor pressure. Okay, because NaCl solution is a mixture of water and salt. So when you add the salt into the water, it will decrease the solvent molecules, or you can say it will decrease the surface which is covered by the solvent molecule, because the number of solvent molecules get decreased, which can escape from the surface from the pure solvent, okay, to create the vapor pressure. That's why the vapor pressure get decreases comparative to the water solution which is in the beaker A. Hence, the correct answer is option first, which says that vapor pressure in the container A is more than that in the container B. Okay, now let's move on to the next one. Okay, this question asks that vent Hoff factor, which is I, is given by the expression. So you simply have to tell the formula or the explanation by which we describe the vent Hoff factor represented by I. The options are I is equals to normal molar mass divided by abnormal molar mass. I is equals to abnormal molar mass upon normal molar mass. I is equals to observed colligative property divided by calculated colligative property. Or I is equals to calculated colligative property divided by observed colligative property. Okay, so you have some time, go through it, and after that we will see the correct answer. Okay, now let's see. So for this given question, the correct answer is option first and third. I is equals to normal molar mass divided by abnormal molar mass, and I is equals to observed colligative property upon calculated colligative property. Okay, so if you see that vent Hoff factor is a measure of extent of association or dissociation of the solute particles, which can be calculated as I is equals to normal molar mass divided by the abnormal molar mass, or this is also equals to the observed colligative property divided by the calculated colligative property. Here, colligative property is a new term, which is basically the property of the solution, which we determine by the ratio of the number of solute and number of solvent molecules, which is present in our solution. Okay, so vent Hoff factor is basically we use to measure the extent of association and dissociation. Association is basically the forming of group of different molecules. Dissociation is basically the dividing of a molecule into different atoms or elements. Okay, so when the solute particles associate or dissociate, what's the extent of that association and dissociation? That will be determined by the vent Hoff factor, and you can mathematically express it as I equals to normal molar mass upon abnormal molar mass, or observed colligative property upon the calculated colligative property. Okay, so both are the option first and third, both are our correct answer for this question. Okay, let's move on to the next one. So this question says that isotonic solutions must have the same water. Okay, so the question asks that the type of solution which is isotonic solution, they have same what you have to tell. So the options are solute, density, elevation in the boiling point, or depression in the freezing point. Okay, so you have some time, go through it, think about it. After that, we will see the correct answer. Okay, let's see. So for this given question, the correct answer is option third and fourth, which is elevation in boiling point and depression in freezing point. So isotonic solutions have same osmotic pressure and same concentration. Okay, so isotonic solutions, ISO. This is important. ISO we are using, which is having something same. Okay, you can relate it to that. So isotonic solutions are solution which is having same as osmotic pressure and the same concentration. Same osmotic pressure, so that the net movement of the solvent will not be there through the semi-permeable membrane. Elevation in the boiling point and depression in freezing point are the colligative properties. And these two colligative properties depend upon the concentration, right? Because if you see that the elevation in the boiling point and the depression in the freezing point both are defined in term of concentration, that is why these two colligative properties are depend upon the concentration, we know. And as the molar concentration is same for isotonic solutions, that's why the elevation in the boiling point and the depression in the freezing point of isotonic solution must be same. Okay, so the isotonic solutions must have same what? Elevation in the boiling point and depression in the freezing point. And thus the correct answer is option third and fourth. Okay, now let's move on to the next one. Okay, so this question asks that for a binary ideal liquid solution, the variation in the total vapor pressure versus the composition of the solution is given by which of the curves? So we have in our options given 4 different curves: first, second, third, and fourth, right? You have to tell that which curve is representing a binary ideal solution and the variation in the total vapor pressure versus the composition of solution. Okay, so you can see we have 4 options, or you can say we have 4 given figures. The first figure is having the graph, okay, between the vapor pressure, or you can say total vapor pressure versus the composition of solution. That means X1 and X2, or you can say this is basically mole fraction, Chi1 or Chi2. This is the graph which is increasing. In the second graph, you can say there is a curve, increasing curve. And in the third graph, we have decreasing curve. In the fourth graph, we have decreasing straight line. Okay, you have to select that which curve is for the variation in the total vapor pressure versus the composition of solution, and it is correctly representing that. Okay, now you have some time to go through it. After that, we will see the correct answer. Okay, let's see. So for this given question, the correct answer is the first graph and the fourth graph. Now how? Let's see. So depending on the vapor pressure of the pure components, first and the second. So first of all, again, let's rewind that what will be the vapor pressure. So what was the vapor pressure? Vapor pressure is basically the pressure which is exerted by the vapor, which is present above the liquid in the chemical term, and in the, you can say, mathematical terms, or you can say for in the formula, you can write the vapor pressure of a solution as the product of the mole fraction of the solvent and the pure solvent vapor pressure. Okay, these two products defines the vapor pressure of the solution. Now, we are saying that depending upon the vapor pressure of pure components 1 and 2, if we have a solution where the two components are present, the 1 and the 2, having the different mole fractions chi1 and chi2, and depending upon the vapor pressure of these two components, the total vapor pressure over the solution decreases or increases with the increase of mole fraction of component 1. Because you can see we have total vapor pressure of the solution is defined as the mole fraction of the solvent and the vapor pressure of pure solvent. You can see the P naught solvent. Okay, so you can define the vapor pressure of the solution as the product of mole fraction of solvent and the vapor pressure of pure solvent. Okay, now depending upon the vapor pressure of pure components 1 and 2, the mole fraction can be chi1 and chi2. You know that, right? For different components, the mole fraction will also be different. Okay, now the total pressure or the total vapor pressure, which is this one, P solution. Okay, so the total vapor pressure over the solution either decreases or increases with the increase of mole fraction of component 1. Now, if the mole fraction of component 1 is here and it is increasing, this will either increase or decrease when the vapor pressure of pure component of first or second changes. Okay, so the graph will totally depend on the you can say vapor pressure of pure solvent, right? Because we have just take a constant thing that the increase of mole fraction of component 1. So mole fraction, this term is increasing. Now, if this is increasing or decreasing, this is depending upon the pure component vapor pressure or 1 and 2. Okay, that means this term. You can see that's why we have two answers for this question, because if the x1 is going from here to here, and if the x1 is increasing, the vapor pressure, or you can say the vapor pressure of pure solvent. Okay, so the vapor pressure of component, the mole fraction of component 1 is increasing. Then if the pure solvent vapor pressure is increasing, then this one will be the graph. And if the vapor pressure of pure solvent for the component is decreasing, then this one will be the graph. Okay, so that's why we have this two correct answers for this question, because the mole fraction, if you take the constant mole fraction which is increasing for one component, then the total vapor pressure of the solution will directly depending upon the vapor pressure of pure solvent of any component. So we can represent the variation in the total vapor pressure versus the composition of solution by the two given graphs. So the correct answer for this question will be first and fourth. Okay. Now let's move on to the next question. Okay. Now this question have a note first of all, which says that in the following questions, a statement of assertion followed by a statement of reason is given. Choose the correct answer out of the following choices. So we have two statements stated as assertion and reason. So basically, we have two statement, assertion and reason. Assertion says regarding the molarity of a solution that the molarity of solution in the liquid state changes with the temperature. That means if the temperature changes, the molarity of the solution changes. The reason says that the volume of a solution changes with the change in the temperature. Now, you have to select the correct option based on the two given statements as assertion and reason. So the options are assertion and reason, both are correct statements, and reason is correct explanation for assertion. Assertion is correct statement, but reason is wrong statement. Assertion and reason both are incorrect statement, or assertion is wrong statement, but reason is the correct statement. what you have to do, you have to read first of all the assertion statement and the reason statement, and then you have to answer, or you have to choose the correct option. Okay, so you have some time, go through it, think about this question, and after that we will see the correct answer. Okay, let's see. So for this given question, the correct answer is the first option, which is assertion and reason both are the correct statements, and reason is the correct explanation for the assertion. Okay, this is the correct answer, which is saying that assertion and reason both are the correct statements. Okay, so the molarity of the solution in the liquid state changes with the temperature is the correct statement, and the reason for the given assertion statement, that is the volume of solution changes with the change in the temperature, is also the correct statement. Okay, let's see how. So basically, the volume of the solution is a function of temperature, which varies with the temperature. This is a simple term, that volume for any solution is a function of temperature. Why? Because volume changes. That means it will increase or decrease when you vary the temperature for a particular solution. Its volume will change. Hence, molarity of the solution in the liquid state changes with the temperature. So, if you talk about the molarity is defined as the number of moles of the solute divided by the volume of the solution. Okay, so and volume of solution in the liters. This is the formula for the molarity. This is the definition for the molarity. Number of moles which is present in 1 liter of solution. Okay, 1 liter volume of solution. So as you know that molarity, in the molarity, the volume term is coming in the denominator. Okay, and volume of any solution is directly depending, or you can say is a function of temperature, because it will change with the temperature changes. When you vary the temperature for a particular solution, its volume will change, either increase or decrease. So as the molarity is also containing, or as the molarity is also consisting the volume in its explanation, so molarity of solution in the liquid state will also change with temperature, because molarity is defined as number of moles of solute divided by the volume of solution in the liters, right? So as you can see that in the molarity formula we are using the volume term. Okay, and volume is depending upon the temperature, because if you heat the solution, if you increase the temperature of the solution, the volume will decrease because the change of state will happen. And if you decrease the temperature of the solution, again the state of the solution will change, and the volume will also change. So that is the reason that molarity of the solution in the liquid state will change with the temperature. And that's why we have assertion and reason. Both the statements are correct. Both statements are correct. And also the reason is also correctly explaining the assertion statement. Because assertion is saying that molarity in the liquid state change with temperature, and reason given for defining this assertion statement is also correct, which is saying that volume changes with the change in the temperature. Hence, the correct answer is the option 1, which is assertion and reason both are the correct statements, and the reason is also the correct explanation for the assertion statement given. Okay, hence the first option is the correct answer. Okay. Okay. Thank you. That's all for today's chemistry class. And wait for some time. Your physics faculty will join you soon. Thank you.